Hi guys, good afternoon. So in the last session we saw about DHCP, DNS, FTP and TFTP. Now today we'll start with the switching. So we have to discuss about switch, VLAN and switch port. About the switch, we have already discussed that the layer 2 device, intelligent device, single broadcast domain, per port collision domain and full duplex device. All these things we have already discussed. Now what we need to understand is about a VLAN. What is a VLAN? See, when you connect devices with a switch, this becomes a LAN. Local area network. What is a VLAN? VLAN is a virtual local area network. Okay. By default, your switch is a single broadcast domain device, right? But sometimes what will happen, let's say, consider a scenario that you have a switch, and with this switch, you want to connect few systems. And these systems, they belong to different departments. Now, for every department, I don't want to purchase a new switch. So what I'll do, I'll connect them to a single switch. Okay. I'll connect all of them to a single switch. Clear? And let's consider this side it is one department, this side it is one department. This is your switch. This is PC1, PC2, PC3, PC4. Okay. The IP range, let's say this is my sales department. This is my HR department. And I don't want them to communicate with each other. Okay. This is my requirement because my sales guys, they are doing their own work. HR guys, they are doing their own work. I don't want them to have communication. Okay. So let's say here, what I'll do is I'll use a network 10.0/24. And this side I'll use, let's say 20.0/24. Okay. Now what? I will assign IP address. This here I'll 10.1 and here 10.2. Here 20.1, 20.2. Now they are connected to the same switch, right? So when I try to ping from PC1 to PC3, will I be able to ping or not? Will I be able to ping or not? What did? You have to see that these are different networks. Now PC1 will be able to ping PC3 or not? They will ping. You think ping? Why? If yes, why? If no, why?
Yes, that was.
Hmm?
Yeah. It tells like data transfer from one side to other side. That's the reason.
Then what's the use of IP address here?
To identify the node inside it.
So this is one network. This is another network. For communication between two different networks, what do you need? For communication between two different networks, which device is responsible? Do we have a router here? If there is no router, how to? There is no router, no communication between two different networks. Or else you could have understood like this also, this PC, if this wants to communicate with a different network, it requires a default gateway. And default gateway IP is what? Router's IP. Again, no router, no communication. So right now they are not communicating with each other. So whatever my requirement was that, okay, I want to use two departments and I want to have one switch. So I'm able to have, and they are not having the communication also. Okay. But the problem here is that imagine this guy will generate a ARP message. Now ARP is a broadcast. And by default switch is what? Single broadcast domain. Definitely. By default, switch is what? Single broadcast domain. Now, single broadcast domain means what? All the ports of the switch, they will belong to the same broadcast domain. So that means this ARP message will come here, here as well as here, right? So that means sales traffic is coming in HR. And if HR guys, they will generate any sort of traffic or any broadcast message. Why this will come? Because by default, your switch has single broadcast domain. So what we are going to do, we are going to break this broadcast domain. And how do you break the broadcast domain? Using VLANs. Okay. This is one reason of using VLAN. Another reason. So this is the main reason is that you want to break the broadcast domain of a switch. By default, switch is single broadcast domain. With the help of VLAN, you can break the broadcast domain, and you can convert your switch from single broadcast domain to multiple broadcast domains. And another reason, imagine this guy here, he changes his IP. Okay. This guy here, he will change his IP to 10.3. Now, PC1 can communicate with PC3 and PC3 can communicate with PC1. Security issue. HR guys, they can connect with the sales just by changing the IP address. Same way, what if this guy will change the IP address to 20.2? Maybe, sorry, 20.2 is already there. Let's say 20.3. So this guy will communicate with the HR department. So you don't want the traffic to be traveling from one department to another department, even if they change the IP address also. And with the help of VLAN, you can achieve it. Okay. With the help of VLAN, even if they will change the IP addresses, even if they are in the same network, they will not communicate. Two devices in two different VLANs will not communicate. Is that clear? So what we are going to do here, we are going to create VLANs, different VLANs. So we'll say like VLAN 10, VLAN 20. Okay. Like this, I can create different VLANs. Now, different VLAN means what? That one VLAN equals to one broadcast domain. One VLAN equals to one broadcast domain. So that means right now, how many broadcast domains? Two. And one broadcast message never leaves a broadcast domain. So that means if this guy now, it will generate a broadcast, it will come here only, it will not go to the other side. And same way, if this guy will generate a broadcast, it will come here only, it will not come into the other side. This is the benefit of using VLANs. So why do you require VLANs? You require VLANs for, you can say, segmenting your network. You can segment your network. Okay. And you can divide the broadcast domain of a switch. So many things you can say, like, divide broadcast domain. Of a switch. You can say you can reduce the size of broadcast domain. Now, what do you mean when you say reduce the size of broadcast domain? Consider this is a 24 port switch. By default, all the ports, they will belong to the same broadcast domain. Once you create two VLANs, now you have two broadcast domains. So let's say 12 ports you have in one VLAN, 12 ports you have in one VLAN. So now one broadcast domain has only 12 ports. Earlier, one broadcast domain was having 24 ports. This is clear. So this way you can reduce the size of broadcast domain also. Clear? Now, if we talk about VLAN, VLAN is a custom network which is created from one or more local area networks, and it enables a group of devices available in multiple networks to be combined into one logical group. So it doesn't matter, in one VLAN, you can have devices of same network also, different network also, doesn't matter. Okay. So the result becomes a virtual LAN. Switch creates a LAN, and when you divide that switch into multiple parts, that will become virtual LAN. Okay. And which will work like a physical LAN only. Same like a physical LAN. It will have kind of capability. Kind of, you can say that, okay, you divide your switch into multiple switches. Because by default, switch is what? One broadcast domain. So if you have two broadcast domain, three broadcast domain, that means three switches are there. Okay. The full form of VLAN is what? Virtual local area network. Okay. So consider this diagram here. It says what? Without VLAN, what is going to happen? Without VLAN, a broadcast sent from a host. Consider there is a broadcast from this host. Okay. This guy here is sending a broadcast. So without VLAN, what will happen? A broadcast message from a host can easily reach all the network devices. Why? Because same VLAN. Okay. I mean, one broadcast domain. So we'll go here also. We'll go here also. Here. Here. Okay, it will come here as well as here. It will go to everyone. But once you create VLANs, what will happen? See, if you don't have VLAN, then message will travel to everybody. Everybody have to process it. They have to check whether the message is for them or it is not for them. So they will have to use CPU for that, and this will create what? CPU overhead. And the extra traffic is traveling in your network, so there will be bandwidth congestion also. It will consume bandwidth as well. Okay. Now let's say you have created VLAN. That okay. This is the port in VLAN 5. This PC is in VLAN 5. This PC is in VLAN 5. So in case you have placed the interfaces on both the switches into separate VLAN, a broadcast from host A, okay, from this host A, the broadcast message will go and it will travel only to this host as well as to this host. It will not go to everyone. It will only go to that dedicated VLAN only. Yes, when we configure the VLANs. Okay. So the host of other VLAN, they will not even be aware of that any communication took place. So these guys, they will never even come to know that some communication took place. This is the benefit of VLANs. Okay. So VLAN in networking is a virtual extension of LAN, and a LAN is a group of computer and peripheral devices which are connected in a limited area like school, laboratory, home, or office building. Why we use LAN? It is widely used for like useful network for sharing resources like files, printers, games, and other applications. So you share resources using the VLANs. And if we talk about total number of VLANs, so total number of VLANs is what? 4096. Okay. Range is range of VLAN 0 to 4095. Out of this range, your VLAN 0 and 4095. Okay. Your VLAN 0 and 4095, these are reserved. These VLANs are reserved. So you do not see these VLANs in the switches. Okay. You cannot see them. You cannot use them. You will see these VLANs in the VMware, not in the Cisco switches or any other switches. In the VMware, you will see this. So remaining VLANs are what? 1 to 4094. So VLAN 1, this is known as your default VLAN. VLAN 1 is known as what? Default VLAN. So why it is known as default VLAN? Because by default, all the ports of your switch, they are member of this VLAN only. All ports of a switch by default member of VLAN 1. And one VLAN is what? One broadcast domain. This is the reason that your switch is by default single broadcast domain. Because all ports of your switch, they belong to the same VLAN. Okay. Then VLAN number 2 to 1001. These are known as standard range of VLANs. Okay, so these are the VLANs that you are able to create, modify, delete, whatever you want, you can do with them. By default, they are not present. You can create them, use them, delete them. That is up to you. VLAN number 1002 to 1005. We call them legacy VLANs. legacy VLANs used in old networks like FDDI and token ring. Now they are not used. You cannot use them. You cannot delete them. Okay. Then VLAN number 1006 to 4094. This is extended range of VLANs. Okay, same like standard range. You have to create them, modify them, delete them as per your requirement. But this range will be available to you only if your switch is capable of running a protocol. There is a protocol in Cisco, VTP, and if your switch is capable of running the version 3 of VTP, then only you will have access to these VLANs. Otherwise, you will not have access to these VLANs. Okay, that means mostly you will be going with these VLANs. Now, by default, what are the VLANs that you will see in the switch by default? So this is one VLAN you will see, and these legacy VLANs you will see. Only 5 entries will be there. One is for default VLAN and 4 entries for legacy VLANs, 1002, 3, 4, and 5. Okay, these VLANs, okay, your standard range and extended range, these are the VLANs that you have to create, modify, delete as per your requirement. And these two VLANs, they will never be visible. Okay, because on the switches, they will not be available. They will be available in the VM. This is clear. Okay. Now, what is the purpose and application of your VLAN? So, purpose of VLAN is used when you have more number of devices in your LAN. You have so many devices, you want to segregate the devices, you can use VLANs. You have lots of traffic on your LAN, you can divide the traffic. When you want that a group of users, they need more security, so you can secure them by creating VLANs. If you think, okay, there are systems which are getting slow because of broadcast messages, you can put those systems in a different VLAN, no broadcast in that. Then after, when you want that user should not be on the same broadcast domain, you want that, okay, these sales department, different broadcast domain, HR department, different broadcast domain. So you can use VLAN. And also you can say you can make a switch into multiple switches. Same like that. What are the advantages of your VLANs? First of all, reduce the size of broadcast domain. Okay, by default 24 ports or 48 ports. But once you use VLAN, you can reduce it. Okay. Allow you to add an additional layer of security. So definitely it will provide security. Make device management simpler and easier. You can easily manage your devices. And if there will be less traffic in your network, less broadcast traffic will be there, less CPU will be used, more security will be there. So obviously your performance of the network will be increased and latency will be reduced. Increased performance, they will provide. Physical boundary, they will remove. How? For two departments in normal scenarios, I had to use two different switches. But now I can use one switch. If I'm using one switch, it will save me some, like I don't have to use any extra hardware or cables or anything. So it will save me some cost also. You can easily segment your network. Then you can enhance your network security. That one department in different VLAN, no other department will be able to communicate there. You can keep your host separated by VLAN. And you do not require any additional hardware or cabling, which saves you some cost as well. These are some advantages of your VLAN. Okay. Now, on a switch, we connect cables. On a switch, we connect cables. So the opening on the switch where we connect the cable, that is known as a switch port. Okay. The interface of the switch, the port where you connect a cable, that is known as a switch port. So on a network switch, the switch port is the physical opening where a data cable can be plugged in. Where you plug the cable, that is a switch port. And generally the switch ports are rectangular on 3 sides and V-shaped point on either top or bottom. Okay, to hold that pin in the RJ45. This is a firewall. Yeah, that RJ45 same. Okay, if you want to see, let me show you here. These are switch ports. Okay, where you connect the TV. Depending on the switch, in some it will be 24, in some it will be 48 also. Like if you want to see. Yeah. These are 24 ports. Okay, these are 24 port switches, these are 48 port switches. Okay. So generally the switch ports are rectangular in shape on the three sides, and there will be a V shape either on the top or bottom. Now your ports on the switch, they can operate in two modes, either as a access or as a trunk. Now what is the access and what is trunk? See, access port is by default member of one VLAN on. Okay, access port will belong to one VLAN, and they can forward the traffic of one VLAN. They will not forward the traffic of another VLAN. And this is the reason that again, you do not have communication between different VLANs. Because your access ports, first of all, I say that, okay, member of one VLAN only. And second thing, they can forward the traffic of one VLAN. One VLAN only. Okay. So your access port, they are generally used for connecting end hosts. Generally used for connecting end hosts. That means your devices like PCs and all. So if I have a switch and here I have a connected a PC, and this port here, if it belongs to VLAN 10, so only VLAN 10 packets it will forward, otherwise it will drop all the packets. This is the reason that you do not have communication between different VLANs by default. Now, what if you want communication for more than one VLAN? Because let's say, for example, I have one switch, I have another switch, they are connected. By default, these ports will be acting as access. And if I have connected one PC here, which is in VLAN 10, and here one PC, which is in VLAN 10. So this port here, by default, it will be member of VLAN 1, the default VLAN. Remember I said all ports of a switch by default member of default VLAN. Okay. So these guys, they will say that, okay, no, this is VLAN 10 traffic and I belong to VLAN 1. I will not forward. Right. So what will happen? You have to change here VLAN 10. What if you have one more PC, which is in VLAN 20? Here also one more PC, which is in VLAN 20. Now, if VLAN 20 guys want to communicate, this will say, no, I belong to VLAN 10, I will not forward. So you have to go and change 20. But what if both will communicate at the same time? Or what if you have 100 VLANs, right? So every time you cannot go and change it. So that is the reason we have what? Trunk port. So your trunk ports, these are by default member of all the VLANs. Since they are member of all the VLANs, they will forward the traffic of all the VLANs. Okay. So your trunk port will be what? By default, member of all VLANs. Okay. So can forward traffic of all VLANs. And these trunk ports, these are generally used for switch to switch connectivity. whenever you want to connect two switches. So generally, when you want to connect two switches, here I will configure it trunk. Here also I'll configure it trunk. Now what? This is member of all the VLANs. Doesn't matter VLAN 10 is there, 20 is there. All VLAN traffic it will forward. Yes. That means you can extend your VLANs across your network. Okay, it is not mandatory that I can have one VLAN in one department or one switch only. I may have my HR department people on my first floor. I may have my HR department people on fifth floor also. So with the help of trunk, I can provide the communication. Okay, so trunk will be generally used for switch to switch connectivity. This is clear. Online people.
But you like, this can be so that here is like actual
This is logical concept. We have to configure it using command. Like in a router, I cannot show you the IP address, that where the IP address you will write, right? So it is a configuration part, logical part. Online people, access port, trunk port, clear?
Clear.
All right. So now let's see how you will configure these ports as access port and trunk port. Okay. Which will have the same user execution privilege and global configuration, same kind of comments. Because switch also uses the same operating system. This is user execution, you enable, okay. You go to the privilege mode. Now let's say you want to check the VLAN information, what all the VLANs are available by default. So you can say show VLAN brief. When you say show VLAN brief, you can see what are the VLANs visible by default. So here you will find VLAN 1, default VLAN, and you will find your legacy VLAN 1002 to 1005. Okay. And also you can see here that all the ports of your switch, F0 by 1, 2, 3, 4, all the ports, they belong to the default VLAN. That's why your switch is the single broadcast domain by default. This is clear. Now, what if you want to create VLANs? Okay, if you want to manually create your VLANs, so you can create VLANs also. VLAN commands are very short. Okay. All you have to say is VLAN and the VLAN number, whatever you want to create. Let's say I want to create VLAN 10. Done. Second command related to VLAN, you can assign a name to it. And this is all the VLAN configuration now. That's it. Okay. Now you can go and check. Do show VLAN. VLAN 10 HR is there. Right? You can see here your VLAN 10 HR VLAN is here. Clear? Same way. Why? Why router? Why do? Just tell me why you think. Yeah, right now I'm using just a switch because we are going to work on a switch. Okay, otherwise in a network you will have router also, switches also, PCs also. Right now I don't have PCs as well. Okay. So all the devices will be there. Right now I'm just getting you familiar to VLANs and all these commands. Okay. Now second thing, let's say you want to create VLAN 20. So VLAN 20 name. Okay. Do show VLAN. Since VLAN is there. But still, see, once you create VLAN, broadcast domain does not get changed. Why? Broadcast domain means what? Membership of the ports. How many ports are members? So that means right now these two VLANs, they do not have any number of ports. So right now, if I say how many broadcast domains you have, so still you have only one broadcast domain on the switch, because still all ports of your switch, they belong to one broadcast domain only. Okay. So we will change the membership. Let's say I want that F0 by 1 should be in VLAN 10. Okay. So how we can do that? All you need to do is go to that specific port, interface, F0 by 1. And here you can use the command switch port access VLAN and to which VLAN you want to add it to the VLAN 10. Now check here, do show VLAN. Your F0 by 1, now it is number of VLAN. Same way, if I want to add F0 by 2 also, 3 also, 4 also, 5 also, I can add it. But if I want to add these like this, then how many times I'll have to run the command for every single interface, right? So let's say I want to add port number 1 to 10 in VLAN 10. So what I'll do, I'll say interface range, and I can select multiple interfaces now. So I will say, okay, I want to select from F0 by 2 to F0 by 10. So only last number you have to change. Okay. Enter. Which port? Access VLAN 10. Do show VLAN 3. Now you can see 1 to 10 they belong to VLAN 10, and remaining 11 to 24 they belong to default VLAN. Now same way I can say 11 to 15 they should be part of VLAN 20. Okay, so I can say that I can say interface range F0 by 11 to 15, which port access VLAN 20. Go and check. Now they belong to this VLAN. Same way, let's say I have accounts department also. So I want that port number 16 to 20, they should be in the accounts VLAN. Okay. So I'll say interface range F0 by 16 to 20. And I'll say port access VLAN. So we didn't create the VLAN, right? So if I try it like this, what will happen? Okay, right now I don't have the VLAN, and if I try to assign the membership directly, what will happen? My switch will say that, okay, this VLAN does not exist. But my switch will also create this VLAN automatically and assign the port. Okay, so without creating VLAN also directly you can go and assign. See here, it will say access VLAN does not exist. So what it is doing? Creating the VLAN pair. Now you can check. VLAN 30 is created and ports have been assigned. Now, if you want to change the name, this is the default name it will take. Okay. So if you want to change the name, now you can go and say VLAN 30. If you want to remove the VLAN, all you have to say is no VLAN 10, no VLAN 20, no VLAN 30. Okay. But if I say no VLAN 30, let's say for example, so these ports, they will not automatically get assigned to default VLAN. They will still be in the VLAN 30. Okay, but the VLAN is not there. That means these ports are now not useful. So if you want to remove the VLAN membership, first of all, remove it from the port. Like no, first of all, go to these ports interface range 16 to 20. No switch port access VLAN 30. Automatically, these ports will go back to default VLAN. After that, you can go and say no VLAN 30. Clear? So what you'll do, you'll say interface range F0 by 16 to 20. No switch port access VLAN 30. As soon as I say this, my ports are back to default VLAN. You can see I don't have anything in the VLAN 30. Now I can say no VLAN 30. Show VLAN. Is that clear? Okay. Interface range F0 by 1 to 24. Switch port access VLAN 1. No VLAN 10. No VLAN. Show VLAN. Default situation. Yes. So how you will create the VLANs? This thing is clear. Now, how do you assign a port as a access port and trunk port? Okay, so see here. Let's say first of all, if I show you show interface F0 by 1 switch port. Okay, this is the command show interfaces F0 by 1 switch port. So you can see right now what is my operational mode is down. Why? Because my port I haven't connected anything here. So let me connect something. Now if I go and check, so my port is up now. Working as a static access. So that means right now it is working as an access port. Now if I want to make it a trunk port, what I'll do is go to that port, interface F0 by 1, then you replace with port mode trunk. If you say this, now check here to show interface F0 by 1 switch port. What is my operational mode right now? Trunk. And if I go and change it, interface F0 by 1 switch port mode access. Now it is static access port. Go to the interface, switch port mode, access or trunk, whatever you will give. That way you can change how your port will behave. This is clear? Okay. So this thing is clear. Now, let's talk about trunking. What is trunking? Creating a trunk interface. Okay. Creating a trunk interface is what? Trunking. Now, if you have two switches, okay, you have two switches and you want to transmit different VLAN traffic. So you will configure what? Trunk, right? And for configuring that trunk, let's say, for example, I have configured here a trunk. These are the two switches. And I have connected them. This is your switch 1. This is your switch 2. Okay. From here, I have connected a PC in VLAN 10. VLAN 20. Same thing here. This is VLAN 10. This is VLAN 20. Always remember your PCs are not aware of the VLAN. VLAN is configured on the switch. So your PCs, they don't have anything to do with the VLAN. And your PCs, they do not understand the VLAN also. Okay. And you want that, okay, they should have efficient communication. So you will configure this as a trunk. Now, if PC 1, 2, 3, and 4. PC 1 will communicate with PC 3. That traffic will belong to which VLAN? 10, because they are member of VLAN 10. So that traffic will belong to VLAN 10. When 2 will communicate with 4, that traffic will belong to VLAN 20. But this is the same wire, single wire. How the switches will come to know that, okay, which traffic belongs to which VLAN? For this reason, on the trunk interface, they will add a tag. They will put a tag that, okay, this belongs to VLAN 10. This belongs to VLAN 20. And looking at that, this tag, your switches will understand that, okay, to which VLAN they have to forward the traffic. Now, for putting these tags, they will use protocols. What protocols they will use? In Cisco, we have Cisco proprietary protocol, ISL, stands for Inter-Switch Link. And for other vendors, we have IEEE.1q. Okay, IEEE 802.1q. This is the protocol. In short, we call it as dot one queue. This is the protocol. And out of these two protocols, always this protocol will be used. Even Cisco is not using its own protocol. Clear? Now let's see what is the difference between these two. So your ISL, it is Cisco proprietary. Your ISL is Cisco proprietary, and even Cisco is not using it. This is IEEE 802.1q. Okay, or in short, we will call it .1q. So this is what, this is open standard. Now, why nobody prefers your ISL? Because it will add 26 bytes of header and 4 bytes of trailer. So that means overall, how much information it will add? 30 bytes of extra information. And whenever you are sending a segment, the size is fixed. Your maximum MTU size is 1500. Okay. So in 1500, it will try to attach this 30 bytes extra information, but you cannot exceed the MTU. So what it will do, it will remove 30 bytes data and then it will put up the tag. That means you are able to transmit less amount of data now. So that's why nobody uses. Your ISL, it will only put 4 byte tag, not even the header, not even the trailer. That means no extra information attached. Only within the original Ethernet frame, it will put a tag. Whatever your original message is there, in that message only, it will include the 4 byte information. And it will try to save this 4 byte also. It has a concept of native VLAN. Okay. So in the .1 queue, the switches, they will agree. Okay. These are the switches connected to each other. This is switch 1. This is switch 2. Okay. And you configure it as a trunk. And here you have same VLAN 10, VLAN 20. Same here VLAN 10, VLAN 20. So on a trunk port, you can configure something called as native VLAN. That means you can tell the switch that, okay, whatever the VLAN I will configure as a native VLAN. If you are sending traffic to that VLAN, then you do not put the tag. Okay, for example, here, let's say I have configured VLAN 10 as my native VLAN. Here also I have configured VLAN 10 as a native VLAN. Okay, so now what will happen when this PC1 will try to communicate 1, 2, 3, and 4. Okay, so when my PC1 will try to communicate with PC3, it will generate a message. The message will come to the trunk port to go to the other switch. Trunk port will see, okay, to which VLAN it belongs. And what is my native VLAN? 10. That means I will not put any tag here. No extra information. I will just forward the frame directly. When the frame will be received by switch 2, switch 2 will try to see the tag, but there is no tag. If there is no tag, switch 2 will say, okay, if there is no tag, I will consider the frame is for my native VLAN, and it will forward it to VLAN 10. But if your PC2 will try to communicate, so it will see, okay, this belongs to VLAN 20, not for native VLAN. So when it will send this message, it will put up a tag. Now, this time switch 2 will see, okay, there is already a tag. VLAN 20, I will forward it here. So by configuring native VLANs frames, they are not tagged. Is that clear? When a switch will forward the traffic to a native VLAN, it will not put a tag. And if a frame is received without a tag, that means it belongs to the native VLAN. And from here, from the native VLAN concept, there is a tricky interview question. What is the question? That interviewer will say, I have 2 switches. Okay, this is the scenario. This PC belongs to VLAN 10. This PC belongs to VLAN 20. Here IP address is 10.1.1.1. Here the IP address is 10.1.1.2. This is switch 1. This is switch 2. Okay. And let's say you have configured here trunk. PC1 will communicate with PC2 or not? Will not communicate. Why? So we configure trunk. What trunk will provide it won't be there. So it is supposed to drop the traffic. Now interviewer will say you have to provide communication. How you will do that? Without a router. Without a router, you have to provide the communication. No, there is no other concept. Same native VLAN concept. How? If I configure on this port as my native VLAN 10, what will happen? When this guy will generate the traffic, it will see traffic is for VLAN 10. My native VLAN is 10. I will not put a tag. Now, if here I want to send the traffic to VLAN 20, I can configure my native VLAN as 20 here. So when the traffic will come without any tag, I will consider what? It belongs to my native VLAN. And I'll forward it here. So by changing the native VLAN, we can have communication. Although you will continuously get log messages that, okay, native VLAN mismatch, native VLAN mismatch. These two links, both the switches, they will continuously give you log messages that native VLAN is not matching. Okay, but still you will have the communication. So sometimes these kind of tricky questions they will ask. Is that clear? Just to check whether how much you know about the native VLAN. Clear? Online people?
Sir, can you please explain it in CLI?
Sorry?
Can you please explain it in CLI mode?
Okay, you mean to see, you want to see it live, right?
This native VLAN example,
Okay, no problem.
the last example you gave it.
So let's go for it. So I'll take two switches, switch 1 and switch 2. I'll take two PCs. Okay, this I will keep in VLAN 10. And this one I'll keep in VLAN 20. And that 0/2 on the both the switches, they will be trunk. Okay. This will be VLAN 10. And this will be VLAN 20. Ten dot one dot one dot one. Ten dot one dot one dot. Okay. Let's go to the switch 1. Interface F0/1 with code access VLAN 10. This is added to VLAN 10. Interface F0/2, switch port, mode trunk. So this one I have configured as trunk. This one I have added in VLAN 10. Same thing I'll do here. Okay. Interface F0/1, switch port access VLAN 20. Interface F0/2, switch port access VLAN. Sorry, switch port mode trunk. F0/2 will be what? Trunk. Done. Fast forward. Now there is one protocol STP which will create some issues here. Right now, if I try to communicate, you will see I will not be able to communicate. There will be no communication. Why? Because this is VLAN 10, this is VLAN 20. So they will not communicate. Okay. We need to change the native VLAN. So I'll go here. By default, your VLAN 1, your default VLAN is configured as the native VLAN. You can check how. Same command. Do show interface F0/2 switch port. So here you can see trunking native mode VLAN is 1 on. Okay. So now, how do you change? So I'll say interface F0/2 to my trunk interface, and I'll say switch port trunk native VLAN, and which VLAN? 10. And this side I'll configure 20. So interface F0/2 switch port trunk native VLAN 20. Done. Let's fast forward. And now let me communicate. What is the status of the port? You see this kind of log you will get. Native VLAN mismatch. And see here, this is the spanning tree protocol which will create the issue. So I'll go here, interface F0/2, spanning tree port first. Here also, interface F0/2, spanning tree port. So you should make sure that your ports are not in the blocking state. Now let me try to communicate. These are in different VLANs. You can see here that I'm getting the native VLAN mismatch. Why? Because here native VLAN is 10, here it is 20. So if it is belonging to native VLAN, this switch will not put a tag. And when this switch will receive without a tag, it will consider it belongs to native VLAN 1. And this is how they will communicate. Yeah. If I change here only by default, it will remain 1 here. I have to change it to 20. Otherwise, it will not forward it to 20. This is it. Clear, Chami?
Yes, sir. So, what is the command for the native VLAN? To set the native VLAN. Switch port trunk native VLAN 10. Okay.
Okay.
Okay. Okay.
Port trunk native VLAN and whatever the VLAN you want to configure as a native VLAN.
Okay.
Or it is like VLAN or VLAN something.
No. Because if native VLAN is 1 here, in that case, the frame will come without a tag. This switch will consider it belongs to VLAN 1. But your PC is in VLAN 20. Again, different VLAN communication will not be there. Okay. So this is how it is. Any doubt? And like I was telling you about the protocol that your Cisco uses, so you can see here. The trunking encapsulation it uses is .1Q only, not ISO. Okay. they will use the .1Q protocol, not IF. Okay. All right. Now the next protocol is DTP, Dynamic Trunking Protocol. Now this is one protocol again, which is not there in the syllabus. And this is the protocol that we do not use in the organization. Okay. Not in the syllabus, not used in the organization, still we will study. Okay. So DTP, Dynamic Trunking Protocol, it is the trunking protocol that is developed, and this is proprietary to Cisco, available only in Cisco switches, which is used to automatically negotiate trunk between Cisco switches. Right now, we configure the trunk manually, switch port mode trunk, right? But with the help of DTP, trunking can be done automatically. Okay. So in your DTP, what happens that there are certain modes. Okay. In your DTP, there are certain modes. So two of the modes we have already discussed, switch port mode access and switch port mode trunk. This is permanent access mode. This is permanent trunk. But if we talk about DTP, in your DTP, we have modes like dynamic auto, dynamic desirable. Now, what is dynamic auto? This dynamic auto mode, this is kind of a guy with the ego, a person with the ego. Okay. How? Understand. There are two people. This is person one, this is guy A, and this is person B. This person A, he's saying that, okay, I will talk to this guy only if he will start talking to me. And then person B is thinking the same thing, that, okay, I'll talk to A if he will start talking to B first. Will they ever communicate? No. Same thing happens in trunking with the switches in DTP. How? You have two switches. They are connected. Now, by default, what will happen? They are in the auto mode. By default, they are set to the auto mode. So in auto mode, what happens that this port of switch 1, this is switch 2. So switch 1 port will say that, okay, if switch 2's port will send me a request for becoming a trunk, I will become a trunk. I'm ready to become a trunk. But the request has to be sent by my neighbor. And this guy here, he is also auto. He is also thinking the same thing. That if switch 1 will send me a request, I'll become a trunk. Otherwise, I'll not become a trunk. What will happen? They will never become a trunk. And they will always remain by default access. This is the reason your switch ports, they are by default acting as a access port. Because the dynamic auto is the default mode that is configured. This is the default mode which is configured on the switches. No, communication will be there. Only trunk will not be there automatically. That means if I connect two switches, automatically this interface will not be configured as a trunk. If you require, you could do it manually. Automatically, this will not happen. Why it will not happen? This guy is waiting for this guy, and here this guy is waiting for this guy. They will never talk. Same situation here. Is that clear? This is your dynamic auto mode. So if somebody will send him the request, he will become a trunk, otherwise no trunking. So this DTP mode makes the interface passively wait for receiving a negotiation message to make itself a trunk, at which point the switch will respond to the and negotiate whether to use trunking or not. So if somebody is sending, I will decide whether I will become or not. But if not sending, then I will never become. I will not send. Ego is there, right? So the switch interface will become a trunk port if the neighbor switch is set to trunk, because if this neighbor, instead of auto, if it is sent to trunk, then it will send a request. And if it will send a request, this guy will become a trunk. Or else, if it is set to desirable, then also desirable will send a request. Name itself says desirable. So this guy will send a request. And if he will send a request, this guy will say, okay, let's become a trunk. No problem. Okay. So same thing. The switch port mode dynamic desirable. This DTP mode lets the port to initiate trunking with another port by sending a negotiation message. So this guy auto is waiting for it, and the desirable is sending it to dynamically choose whether to start using trunk. So this interface will become a trunk port if the neighboring interface is set to trunk, Because if the neighbor is set to trunk, let's say this side it is desirable. So this side it is trunk. So both will send the negotiation request. They will become a trunk. If neighbor is auto also, he is waiting, he is sending, they will become a trunk. And if both sides desirable are there, both are sending, they will become a trunk. So the interface becomes a trunk port if the neighboring interface is set to trunk, dynamic desirable or dynamic on. And since, like I said, in the organization, we do not use DTP. So to disable DTP, we use this command. Switch port, no negotiation. So this command will disable DTP. Is that clear? Okay. Now, let's see how, in which case the trunking will be there, in which case trunking will not be there. So these are certain modes. Okay. You can consider two switches. And they are connected. This is switch 1. This is switch 2. This is switch 1 port. This is switch 2 port. So these are the modes for switch 1, let's say. And these are the modes for switch 2. So if switch 1 port is desirable, this is desirable, and switch 2 also desirable. Both are desirable, that means trunking will be there. If switch 1 is auto, switch 2 is desirable. One is auto, one is desirable. One is waiting, one is sending. They will form a trunk. Then trunk and desirable, they will be trunking. So this will be a lot of things to remember. What is the easier way? Easier way to remember is if anyone out of these two, if anyone is access, okay, if anyone is set to access, there will be no trunking. So you can see here this guy is access, here no trunking. Here this guy is access, no trunking at all. So if any one of them is set to access, there will be no trunking. And if both are auto, which is the default case, then also no trunking. Rest of all the cases, trunking will be there. So here this is auto and this is auto. So here there is no trunking. Rest of all the cases here you can see everywhere trunking is there. So you can remember these two things, that if any one of them is access, no trunking, and if both are auto, no trunking. Rest of all the cases, trunking will be there. Is that clear? Now let's go and see DTP, how you will configure it. So I'll take 3 switches. These are the 3 switches. Now by default, first of all, let me show you that these are in the dynamic auto mode. So interface F0 by 1, and I'm checking, you can see on the switch 1. Switch port. What is my default administrative mode? Dynamic auto. Same way, this will be dynamic auto, and dynamic auto. Everybody. And because both are auto, they will never become a trunk. So my operational mode is what? Access. Same way, this is access, access, and now if I want to configure trunking between the switches, so without DTP, I have to manually go to these interfaces and I have to give the command switch port mode access. Sorry, switch port mode trunk. Manually, I'll have to go and give the command here. But now I want to use DTP here. Although DTP is already enabled, you can see here, dynamic auto, DTP is by default enabled. Okay. So what I'm going to do here, that I will just, in normal scenario, 1, 2, 3, and 4 times I have to run the command. But now what I'll do, I'll use DTP, and with the help of DTP, I'll configure this F0 by 1 and F0 by 2 as a desirable. So these two interfaces will be desirable. This is auto and this is auto. Guys, wait for a moment, please. Okay. So what I'll do, I'll go and configure these two interfaces as desirable, and these are already in the auto. So these two interfaces will send the request, and these are waiting for the request, and everybody will change their mode to trunk. Okay. So let's go to the switch to. And also there is one more way you can already check whether there is trunk interfaces available or not. How can you check? You can give the command show interfaces trunk. Right now you see there is no output. That means there is no trunk interface at all. Now let's go to the interface range F0 by 1 and 2, and I'll say switch port mode dynamic desirable. Same like that. Okay. Switch port mode access trunk, we were saying like this. Here we will say dynamic, auto dynamic desirable. Okay. Now let's go and fast forward, or else directly you can go and check to show interfaces trunk. Do you see? Wait one moment. Okay. So you can see now F0 by 1 as well as F0 by 2. Both are what? Status is fine. Okay, and like this also you can check interface. Do show interface F0 by 1 switch port. Now you'll see the mode is fine. Okay, so this way automatic. On switch 1, I did not execute any command, right? So if I go and check on switch 1, earlier it was access. Now let's go and check. Same command. Mode is down. This way, with the help of DTP, we can configure. Okay. Yeah. All right. Now there's one more protocol. Again, not in the syllabus, not used, or not, we cannot say not used, but we avoid using this protocol in the companies. Why we avoid? Because sometimes this can lead to a disaster, this protocol. A slight mistake and you're out of the company. Okay, that kind of disaster this is. So, no, we don't use VTP also.
So if we don't do it, there will be no interview for this.
They will have. Interview questions will be there. Okay. So another protocol is VTP, VLAN trunking protocol. Okay. So this is the protocol that says trunking protocol, but this is not a trunking protocol. This is not used to make a trunk. So first of all, name is confusing. Second, this protocol is used why? So that you don't have to manually go and create the VLANs. Let's say, for example, in your company, there are 5 floors. On 5 floors, you have different departments. Okay. So you want that, okay, VLAN 10, 20, 30, 40, 50, they should be created in each and every floor switches. Okay. So one is you will manually create it. With the help of VTP, they will be automatically created. This is the use of VTP, that your VLANs, they get created automatically. Okay. So for example, I have, let's say, a building 3 floors. 1, 2, like this. They are connected. Okay, so my company says, okay, you have to go and create VLAN 10, 20, 30. I'll go and create 10, 20, 30. Same thing here, I'll do 10, 20, 30. Here also I'll do the same thing, 10, 20, 30. Manually, I'll have to go and do everything, right? My company says remove the VLAN 30, not required. I have to manually go and remove. But with the help of VTP, what will happen? This will be done automatically. Okay. So how VTP will work? In VTP, we have modes. What are the modes? Server mode. Then we have client mode. Okay. So let's say this is one is server and these are set to client. So in the server mode, you can create the VLANs. And this is the default mode. That's why in the switches, we are able to create the VLANs. VTP also by default enabled in the Cisco switches. Okay. So by default, your switches are in the server mode. In the server mode, you are able to create the VLANs, modify, delete, all those things you are able to do. And your server switch, whatever the VLAN you will create, so it will advertise everything. It will advertise to the neighbors. And the client switches, you cannot create the VLANs. If you try also, it will not allow you to create. Okay. So these client switches, they will receive the advertisement from the server. And then whatever the server will say create 10, they will create 10. And this client will update its database and it will forward here. So this client will also say create 10. Server will say create 20, immediately update it 20, 20. So you don't have to manually create it. The VLANs, they will get created automatically. So we say that, okay, VTP is used for what? For synchronizing VLAN database. That all the switches, they will synchronize their VLAN database. But sometimes, there can be situation that, okay, this is one floor where I don't need my HR or sales or like VLAN 10 or 20. Okay, let's say here you want to create HR, sales. Same thing you want to create here, HR, sales. But this is one floor where your accounts department is there. Now you don't want this HR and sales VLANs here, right? So if I'm making it as a client, definitely it will create, because in the client manually, I cannot create a VLAN. It will take the advertisement from the server and update it. So I cannot create it as a client. So what I'll do, I'll create it as a third mode, which is transparent. What is the responsibility of the transparent? It will take the advertisement from the server and forward it to the client. It will not change the own database. Its own database, it is not going to change. Okay. And whatever the VLAN you will create here, in the transparent we can create, in client we cannot create. So whatever the VLAN you will create in the transparent, it will not advertise. It will not share with server or client. It will keep it secret. Yes, we can separately create here in the transparent. Is that clear? So this is the use of these modes. Now let's see the theoretical part. Then practical implementation also I'll show you, and I'll show you how it can be disaster. So VTP is a Cisco proprietary protocol. Yes. Okay, you want to set VTP is a Cisco proprietary protocol, and it is used to maintain the consistency throughout the network. Okay. Where, or you can say that you want to synchronize the VLAN information in your VTP domain. Now, domain means what? Network or part of network. Okay. So VTP allows you to add, delete, and rename VLANs, which is then propagated to other switches in the VTP domain. So server, in the server, you can create the VLANs, and server is going to do what? Advertise it to other switches as well. Okay. Then VTP advertisements can be sent over 802.1q or ISL. That means over the trunk link also, your VTP advertisements will be sent. This is clear? Okay. Now there are certain requirements for your VTP. Okay. That what are the requirements? Number one, that whatever the version you are using for the VTP 1, 2, 3, so that version must be same. Okay. The VTP version must be same. Your domain name, whatever you configure, that must be same. One of the switches must be a server. So one of the switch must be acting as a server. And if you have applied authentication, then the authentication should also match. These are requirements. Okay. And about the three modes that we were talking about. Server. So in the server mode, you're able to create, modify, and delete the VLANs. Okay. And here, this is the default mode. That's why in all the switches, we are able to create the VLANs. No, by default, all are server. We have to change it to transparent and client. Okay. By default, all of them will be the server. So the changes you want to make should be done in this mode, because only in server you can create the VLANs. And any changes that is done in this mode will be advertised to all the switches that are there in the same VTP domain. This is clear? The client mode. So client is responsible for receiving the updates from the server and then updating its own database. So in this mode, the switches, they will receive updates and they can forward the updates to other switches. Okay. And these updates, they are not saved in the environment. This is not permanent configuration. Why? Because switches will continuously update. Server switch will continuously send update and you have to continuously change. So in permanent memory, you cannot do all these things. It will remain in the RAM only. That means you restart the switch, VLAN wiped out, again server advertisements will be there, and again you will create the VLANs. Okay. So all the configuration will be deleted if the server is reset or reloaded. That means the switches will only learn it and pass the VTP summary advertisement to other switches. Okay. And if you talk about the transparent mode, this mode is only going to forward the VTP summary advertisements through the trunk link. Take it from the server, pass it to the client, doesn't have to do anything in its own database. Okay. The transparent mode switches, they can make their own database, like accounts VLAN we created, right? So they can create their own local database, which they will keep secret from other switches. So they will not announce it to any other switch. Okay. And the whole purpose of your transparent mode is what? To forward the VTP server advertisement, but not take part in the VLAN assignment. So that means take it from the server, pass it to the client, do not do anything in the local database. Okay. So these are the three modes. Now let's see how you will configure it. VTP comments are also small only. So this one switch, I'll configure it as a server. This one we will make it as a transparent. And this one we will make it as a client. Okay. So let's go and change the modes. VTP comments are very small. You will say VTP mode client to change the mode. Same way here you will say what? Transparent. VTP mode transparent. And let me change the name also. Host name transparent. So that we can know on which switch we are working. And here let me change it to client. And here this is our server. And you can see default mode is server only. How you can check? Show VTP status. So default mode is what? Server. Okay. And this switch is capable of running VTP version 1 and 2. And right now it is running what? Which version? Version 1 only. Okay. So let me change the host name. Server. And it is already working as a server, so I don't have to do anything. Now what? Let's focus on the requirements. So first requirement was what? That version must be same. So let's go and configure the same version here. I'll say VTP version 2. This is the latest version available in this switch. By default, it will use 1. Still, it is the same only, but I want to use the latest one. Okay. And here, VTP version 2. Here also VTP version 2. First requirement done. Okay. So it says you cannot modify it in the client mode because it will take the advertisement from the server and then it will modify. Okay. So let me do one thing. VTP mode server. And now let me change it. Done. In the server mode, we can make the changes. We cannot make the changes in the client. And now I can set it back to client. VTP mode. Now we have to configure the domain name. So how do you configure domain name? You say VTP domain and cisco.com. Configured. Same thing you configure on the transparent. VTP mode. Sorry, domain. Cisco. Done. Let's go and configure on the client. VTP domain cisco.com. Done. So you see it already took the advertisement from the server and already configured it. Then after, next requirement is what? That one of the switch must be a server. So already we have a server. Now what? Let's go and create the VLANs. So I'll go here. I'll try to create the VLANs. Okay, so I will create it in the server switch and I will check it in the client switch. Okay. Do show VLAN B. You can see default VLANs are there. I'll say VLAN 10. Okay, and let's say host name. Sorry, not host name. Name. VLAN name is HR. Now if I check, do show VLAN B. You can see my HR VLAN is created here. This is the server switch. I did not configure anything on the client switch. Let me go and check here. Do show VLAN B. So if you see here, HR VLAN automatically created. Okay. And if you check in the transparent, so in transparent, it will not be created. Do show VLAN B. Okay. So transparent role is what? It will take it from the server and pass it to the client. That's it. Now, if I try to create inside the client switch, where's one more? Okay, so if I try to create it in the client switch, if I say VLAN, let's say 20, it will say VTP VLAN configuration not allowed when the device is in client mode. So in client mode, we cannot create the VLANs, only in client mode. Once you set VTP mode client, now this guy cannot create the VLANs. Now it will accept the advertisement from the server and then it will update the database. Server says that, okay, create the VLAN 20. VLAN 20, name, let's say sales. Go and directly check in the client. Okay. Server says, okay, no need of VLAN 20. No VLAN 20. Immediate updates. And nothing will happen here in the transparent. And if you create here, VLAN 100, name accounts, do show VLAN 3. You created it in the transparent. So this VLAN will not be advertised to anyone. Okay. These guys, they will not know about this VLAN. Clear? And now this thing is clear. We can have more transparent also, more client also we can have. Okay. Now if I check do show VTP status. So in VTP, what happens that there is something called as configuration revision number. That means how many times you have modified the VLAN configuration. So I have modified it 6 times. Okay. Every time you execute a command VLAN, no VLAN, name. So every time what will happen, this will increase by 1. And your clients, they will accept the advertisement from the highest revision number. They will receive the updates or they will accept the updates from highest revision number. And even your server will do that. Now let me explain the case when this can be a disaster. So let's say this is your network running very smoothly. You have hundreds of VLAN configurations. Now what? That suddenly in one of the department, one of your switches down, not functioning. Now what you did in your inventory, you had a switch, old switch. So this is my old switch. This is my old switch. And this old switch, it was my bad luck that this was a server in the old time, right? So let me configure VTP here. Host name, let's say old server. Okay. So VTP mode server already exists, VTP version 2, VTP domain cisco.com, because it was the same company switch, so all the configuration was there. Okay. And this is done. Now I'll say VLAN 10, VLAN 20, VLAN 30. VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, and interface 0x1, switch port mode dynamic desirable, no VLAN 50, no VLAN 40, no VLAN 30, no VLAN. I'm just changing the VLAN database so that configuration revision number will be high, because this was old switch has been used for a long time, so multiple updates were there. Okay. No VLAN 10. So now if I check to show VTP status, so you can see its configuration revision number is 10, right? And let me create one VLAN here, VLAN 999. Name, I'll give it goodbye. Okay. To show VLAN, just 5 minutes. Okay. Now this was the switch which was having a lot of configuration. Your network is running smoothly. One of the switch failed, and what you did, you took out a old switch from the inventory. and that old switch was server in the old time, right? And without testing it, you just wanted to check whether this switch will work or not. And what you did, without checking this switch, you connected it to a network. As soon as you connect it to the network, this is having high configuration revision number, and your clients will accept the updates from high configuration revision. Even your server will do that. That means all VLANs from your entire network will be immediately wiped out. If all VLANs are wiped out, all your departments, all your security is down. And if all the security is down next day, you know what happened. Right?
Sending all this.
Yes. Exactly. See here the magic. Earlier you had your HR VLAN here. What do you have? Goodbye. In the server also, not even just client. Check here, the server. Goodbye. And these VLANs, VTP, it is in the RAM only. No backup also. You are gone. Okay. So that is the reason you have to be very careful when using this. A slight mistake, entire network wipe out. Okay. And if you want to avoid this kind of thing, first of all, don't use VTP. And if you want to use, see, VTP doesn't have really big benefit, because with VTP, what you can do, you can just send the VLANs, but to the ports, the membership, you have to manually go and assign there. So if you have to manually go and assign the membership, you can just give 1 or 2 extra comments, right? So better than using it, don't use it. Or else if you want to use it, then while connecting any old switch, okay? See, why this old switch was able to wipe out your VLANs? Because of high configuration revision number. So what you can do, before connecting this switch into your network, you say VTP mode transparent. Once you make it transparent, your configuration revision number will reset. And transparent switch never advertises the VLANs. This way you can be seen. Is that clear? So this is your choice. You want to use it, be careful, or else just don't use it. Is that clear? Online people? Guys, clear, right? Okay. So this was your switch, VLAN, VTP, DTP. This is clear. Now tomorrow we'll start with the protocol STP. Okay. That's it for the day, guys. Have a good day. Bye-bye.